Okay, our last integration by parts video, I've set up this example ahead of time so that we can get on with it, but if you look here, I've got x squared e to the 2x, and if I follow again the I late sequence, I let u equal x squared, and I've done that here, and then dv would be e to the 2x dx. Well, the derivative of x squared is 2x dx. The antiderivative of e to the 2x is 1/2 e to the 2x, right? Because antiderivative of e to the 2x is e to the 2x. Divided by the derivative of 2x, which is 2, so 1/2. Now look what I get. When I go uv, I get half x squared e to the 2x, which is, whatever. But then minus v du, half of 2 is 1, so I get x e to the 2x dx. Well, you notice here I have something that looks really similar to this, just a little bit more simple. I'm going to need to use integration by parts again. So I want to show you something we can do when u is an algebraic expression. So here's the same problem, but I'm going to use something called tabular integration here. Okay? Now tabular integration, I think you're going to like this, will work especially when you have an algebraic u and you can differentiate it all the way down to 0. So watch what we're going to do here. We're going to make a table of u and dv. So u is, using I late, would be x squared, and then dv would be e to the 2x dx. Now we're just going to put the e to the 2x here because the dx will take care of itself by the end. So watch this. What I'm going to do first is I'm going to differentiate u all the way down to 0. So in other words, the derivative of x squared is 2x, then the derivative of 2x is 2, and then finally the derivative of 2 is 0. I'm going to find this many antiderivatives for dv. So the antiderivative of e to the 2x is e to the 2x divided by 2. The derivative of half e to the 2x is half e to the 2x divided by 2 again. So that would be 1/4 e to the 2x. The antiderivative of that would be e to the 2x divided by 2 again, which would give me 1/8. Now, what am I doing here? I'm going, if you look at the previous page, I go uv minus v du. Then if I would do this again, I would have to let u equal x and dv equal e to the 2x dx all over again. And I'd go uv minus v du again. You notice signs alternate. The uv is positive, the v du is negative. So what ends up happening here is this is u and this is dv. I'm going to go on a diagonal. If this is dv, this is the v for this u. I'm going to always multiply on a diagonal. And because it's uv minus v du, the signs are going to alternate. You're always going to start out plus, then minus, then plus that. Okay? So if I watch this, this is half x squared e to the 2x minus 2x times 1/4, that's half x e to the 2x, then plus 2 times 1/8 is 1/4 e to the 2x. And then, of course, since it's an indefinite integral, plus c. This is the antiderivative for that expression, and that's called tabular integration. It's a better option than integrating repeatedly. Okay? Here's another example. X to the 4th e to the x dx. If I let u equal x to the 4th, I'm going to get 4x cubed, and I'll have to keep going. So tabular integration is going to work great here with that algebraic u. So x to the 4th, and let dv be e to the x dx. So differentiate down to 0. 4x to the 3rd, 12x squared, 24x, 24, and then finally 0. Antiderivative of e to the x is e to the x over and over again. So look at this. I'm going to have 1, 2, 3, 4, 5 terms in my answer. I would have had to have done integration by parts 5 times. So let's see here. So I have x to the, so remember to alternate signs, plus, then minus, plus, then minus, then plus. So I've got x to the 4th, e to the x, minus 4x to the third e to the x plus 12x squared e to the x minus 24x e to the x plus 24 e to the x. And then, of course, plus c. And there's your antiderivative. And there we go with that. Now the last one is a little bit unpleasant, but we are going to find the antiderivative of this. Now watch, this is kind of weird. We want the antiderivative of e negative x sine of 2x dx. So using I late, I got this trig function. So what I'm going to let do here is I'm going to let u equal the sine of 2x, and then dv will be e to the negative x dx. Now the derivative of u will be the cosine of 2x times 2 dx. The antiderivative dv is, the antiderivative e to the negative x would be e to the negative x divided by a negative 1, which would be negative e to the negative x. Now watch what happens. uv, I get negative e to the negative x sine 2x minus the integral of v du. Well, minus a negative, that's going to be positive. Integral, there's a 2 out front here, e to the negative x cosine 2x dx. Now you look at this and you say to yourself, man, that's no better than what we started with. So you say to yourself, well, I'm going to have to use substitution again here, or integration by parts again. So again, I got a trig function. I'm going to let u equal the cosine of 2x, and dv would be e to the negative x again. Squeeze in a dx there. So du would be negative sine 2x times 2 dx. And again, v would simply be negative e to the negative x. So multiplying. Now, remember, I've already got this first term, negative e to the next, negative e to the negative x sine 2x plus 2 times. Now, I did integration by parts with this, so uv, negative e to the next cosine 2x minus v du. So minus a negative times a negative, so 3 negatives, that's going to be negative the integral of v du. So I get a 2 here, bring that outside, e to the negative x sine 2x. dx. Now what you notice here is this integral I have is the same integral that I started with. Now watch how we're going to use that to our benefit. Okay, so what we're going to say is the original problem, the integral of e to the negative x sine 2x dx, I now know is equal to this entire expression, which is negative e to the negative x sine 2x. And then if I distribute the 2 here, I get minus 2e to the negative x cosine 2x. Distribute the 2 here, I get negative 4 times the integral of e to the negative x sine 2x dx. Now what I can do here is, since I'm just trying to find out what the value of this is, I can take these negative 4 e to the negative 2 sine x and add them to the other side. Nice A. Add to both sides. So if I add it to this side, it's going to cancel. Add it to the other side, I'll have 5 of these over here. 1 of these plus 4 more. I've got 5 of this integral equals all this stuff. So cosine 2x, and there we have it. Now the last step is, I'm trying to find the value of this, right? Well, just get rid of this 5. Divide both sides by 5. So my final answer is going to be negative 1/5 e to the negative x sine 2x minus 2/5 e to the negative x cosine 2x, and then plus c. And that's it for integration, repeated integration and tabular integration.